Good day, everyone. Welcome on yet another UFE Academy lecture. Today we have here with us expert from Nicolaus Copernicus University in Toruń, from the Faculty of Earth Science and Special Management, Dr. Aleksandra Pospieszyńska.
Hello.
Welcome. I'm so glad you were able to join us. Dr. Aleksandra will tell us about the climatic problem. But before we'll dive into that hot topic, I'd say, let me tell you more about UFE Academy. UFE Academy is a series of open lectures, sessions like this one, happening across UFE Alliance. And if you'd like to join, me, Anna Kurworska, UFE Academy Coordinator, would be thrilled to have you join our European classroom. For the whole offer, remaining and also future, go to the ufe.eu/academy website. And finally, rule of this session. If you are watching us now in a live version and have any question during the lecture, you can always drop it in the chat, and at the end, I will read it to our expert. But if you are watching us afterwards, then just use comment session, and I will make sure to pass your question also to Dr. Aleksandra. All right, let's get started.
Good afternoon, everybody. Do we really have a climatic problem? I believe that all of us are concerned about climate change we are observing. However, often in media we have very, very drastic images about climate change, but unfortunately in this discussion we often forget about scientific facts. So today I would like to give you some quick view on this issue about climate change, about climate system, so that you have knowledge about the climate system and the changes in it. Afterwards, we will have this Q&A session, and I would like to hear about your concerns about climate changes. In general, the first question I would like to ask is, are we truly living on a burning planet? This question is raised by media, and also you can find the information in official streams, like this. WMO, World Meteorological Organization, is the main organization which simply work with climate and climate changes, and this is the press release from the 10th of January this year. In this press release, as you can see, we can find the information that 2024 was the warmest year on record at about 1.55 centigrades. This is, of course, the information for the above the instrumental level. That means before this industrial era. Moreover, the 2024 was hot not only in some regions. As you can see here, the information about very hot day in China, or few days in China in April, but also this 1.55 was the highest temperature on Earth. Moreover, before this press release, 3 days before, we could observe those images. Those are images from Palisades, from Los Angeles. The big wildfires, we all remember, these videos and pictures from this event. So very extreme weather, very extreme situation, drought, and very high temperatures causing this kind of wildfire in California. What else happened? In 2024, we have this big flood in Central Europe, Germany, Czech Republic, Slovakia, Poland, and other countries were simply damaged by big precipitation and flooding. which is quite important for us because, for example, for Poland, in this area in 1997, we have something which was called, the event called the flood of the millennium. So only 30 years passes and we have another flood of the millennium because the levels of the water were more or less the same as in 1997. So as you can see, we can observe very extreme events, not only in Europe. The Europe is very close to us, yeah, but we can observe also those extreme events. For example, here information from September, yeah, this year, the F5 tornado, so very intensive, very strong tornado appeared in United States. And here you have the list of F5 tornadoes, so the most extreme tornadoes from the last 30 years. So as you can see, we have plenty of examples of this extreme event. Not only tornadoes, not only flooding are the danger connected with climate changes, but also we can find the information, for example, here about global drought risk. Drought is also very extreme event, but unfortunately it also influences the agriculture, and the damages, for example, in fields of crops, can lead to very serious problems with food production and also with hunger. So this is the problem which we facing right now. Also, this connection between floods and droughts, we have also example from the last year, from September, from Poland, that in the south we have flood, in other parts of our country there was drought. So both of those extreme events can appear at the same time. As we look at those images, as we look in media, often we have very flashy headlines of those informations, and not only flashy headlines, but often this is only a clickbait. We need experts, we need more scientific view in the problem, because I don't want you and I don't want my knowledge to be cut and present like this. So, ladies and gentlemen, let's start, and I want to show you and describe how Earth's climate system works. Understanding this climate system is crucial to understand climate changes. First of all, we have to take into the consideration the difference between climate and weather, because unfortunately our policymakers often mixed those terms. And please remember, weather is the temporary, at moment of speaking, situation and state of climate elements, meteorological elements, for example, air temperature, precipitation, cloudiness, solar radiation, and climate. Climate, this is the, as you can see, this is the average state of climate system, which includes atmosphere, ocean, cryosphere, biosphere, and lithosphere. This is the definition of climate, which includes all elements of natural environment. To see how it works and to see all those elements, you can look quickly on this graphic, because cryosphere includes glaciers, lithosphere includes lands, and also includes all processes which are appearing in this element. Biosphere, atmosphere, and hydrosphere are connected, and as you know, those connections are quite important for us as humans. And now, lithosphere includes continents, mountain ranges, ocean basins, sediments, and soils. What is very important, this sphere has quite big memory for climatic events. That means the climatic events can be written in this sphere, and the climate signal will last for very long time in this sphere. The most rapid interactions between lithosphere and atmosphere are explosive volcanic eruptions, which can really influence climate all over the Earth. Next sphere, this is cryosphere, so it includes global resources of ice, snow, and permafrost, so water in solid state. It is very important sphere because it has a very large albedo and plays very important role in climate processes, and also it is very good indicator of climate changes. Next sphere, this is hydrosphere, which includes liquid water, and this is very good energy storage for Earth. It's absorbing solar energy over varying timescales. That means that this element of climate system can give us information about the weather, which appears weeks ago, months ago, but also it can provide us information about past climate. It is connected with the oceanic circulation. Next sphere, this is biosphere, and this is also known as ecosphere. So this is the global sum of all ecosystems available on Earth, and this is also very good indicator of climate changes, not only contemporary but also those paleoclimatic. So from this biosphere, from previous eras, we have excellent information about climatic conditions. And the last sphere, this is of course atmosphere. This is the most dynamic component of the climatic system. It has very short term memory for people living in Central Europe. We all can observe the big dynamic, for example, now during the fall, when the weather can change not only from day to day, but also from hour to hour. So this is very dynamic element. And as you can remember from your, for example, high school, this sphere is not, it is also divided in different layers, and each layer has its own features, very important features, also for modeling the climate. Okay, so how it works? Simply, how it works. First of all, ladies and gentlemen, I would like to say that we often also hear the information that greenhouse effect is bad for us. No, this is natural phenomenon. Without a greenhouse effect, we won't be able to live on Earth. However, human activity can enhance this effect, and this is bad for us. But this greenhouse effect is natural effect which is connected with solar radiation, which is short wave solar radiation, which can add energy to the climatic system. And because of this solar radiation, all processes can go on. The problem with this enhanced greenhouse effect is that we receive more energy. We can simply, the system receive more energy that it can simply use. What does it mean? We have imbalance. Clearly, imbalance energy. This imbalance is connected with oceans, and this imbalance indicate an accumulation of heat. That means we have more and more energy in our climatic system. And as is written here, this may appear small, but this is the amount of 0.6 watts per square meter, and we have to multiply by square meters we have on Earth. That simply talking, simply saying that gives us very big amount of energy, which is imbalance in climatic system. In idyllic scheme of solar energy, we have zone, clearly visible here, zone with surplus energy. So it this zone receives more energy from Earth that is simply loosed by a short wave, by long wave thermal radiation, and from 40 degrees south to the pole and from 40 degrees north to the pole, we have deficit in energy, so those places receive less energy that they need. And simply this imbalance also leads to the fact that it should be here, when I'm sitting, it should be simply polar region, but fortunately we have atmospheric circulation, oceanic circulation, and other elements which can simply spread this energy, spread heat all over the Earth. So how it works? In general, between each and every element of climatic system, we have different kind of interactions. Those interactions are shown also in this picture, where you can find, for example, interactions between hydrosphere and atmosphere. For example, we have a very visible heat exchange. We have also interactions between atmosphere and ice. The sea ice can simply reflect a lot of energy from sun, and lack of the sea ice may lead to simply overheating the ocean. What else? We have also influences between the soil and atmosphere, soil and biosphere, and also soil and water in the soil. So those interactions are very complicated, and when we want to talk about the climate changes, we have to take into the consideration those interactions. I would like to say some more about this element of climatic system, because in climate models we have this one of the elements, is cloudiness. And cloudiness, it is very difficult to describe, because depends on the type of the clouds. We have different reaction of the climatic system. For example, we all know those beautiful clouds, high clouds called cirrus, And those clouds can simply, they allow the solar radiation to go to the Earth surface, but also those clouds, as we all know, in presence of clouds can stop the heat from Earth to go to the upper atmosphere. That means when we have clouds, we have quite nice temperature. This is mainly during, for example, during the nights. So each and every cloud can stop the energy from flying away, but for example those low clouds, this is stratocumulus cloud as an example, reflects more most of the solar radiation. That is the different interaction of clouds with solar energy. And as you can imagine, in general, clouds cooling down the climatic system. A very important element of the climate system is a carbon cycle. This carbon cycle includes the changes in biosphere in general and in this short term, but on the other hand, this carbon cycle can also lead to catching the carbon in, for example, in different kind of sediments. We have different influxes of carbon, but in general, we can say that carbon cycle can be rapid or slow. What does it mean? Rapid carbon cycle is the process of carbon exchange in non-geological timescale. What does it mean? It lasts, for example, during the vegetation season. We can observe now the change in biosphere. For example, in Central Europe, we have beautiful fall, and this carbon, which was caught by plants at the beginning of the vegetation season as a part of their matter, is now letting off to the atmosphere because of the ending, of this vegetation season. Moreover, this short-term scale also concerns the lifespan of most of organisms. So this is very, from geological point of view, this is very short-term cycle. On the other hand, we have this slow carbon cycle, which is connected with, for example, the sediment layer. This is also connected with the all processes in soils. And for example, here we have the sequestration of carbon, for example, in peatlands. So wet places, wet ecosystems. And to list the elements of carbon cycle, we have the information that this is atmosphere, biosphere, soils, also lithosphere, and seas and oceans. What does it mean? Well, carbon cycle is very closely related and connected with climatic system. And what about climate changes? Yeah, because this is the very hot term. Well, in media we can find the interpretation that climate change, this is everything happen in weather. Yeah. Well, that's wrong, because based on the definition by World Meteorological Organization, climate change, this is the difference, I will read it, this is the difference between consecutive averaging periods is large enough to exceed the so-called climatic noise. So this is the real definition of climate change. We have to take into the consideration also this statistical nature of climate change. We often hear the term climate trend, or trend of air temperature, trend of precipitation, so on and so forth. And trend, this is the climate change which is characterized by balanced, monotonous increase or decrease in average values during the observation period. Why this is so important, this observation period? Because we can talk about trends in climate when we have at least 30 years of observations, 30 years of data. For the shorter period, we can say about tendencies, but if we want to talk about trends, we have to have this 30 years of observations. And what are the causes of climate change? Based on the nature of those causes, we can simply look at the climate change in different time scales. Because when we take into the consideration, for example, continental drift, that means the changes will last for millions of years, hundreds of millions of years. But if we take into the consideration, for example, volcanic activity, those changes in climate system can last, for example, for a year or 2 years for very big explosive eruptions. And as you can see here, with volcanic activity, we have this term year without the summer. So for the big eruptions, we have a very big amount of ashes going into the troposphere to the stratosphere, and this may cause very cool temperatures on Earth because of the reflection of solar radiation. Other causes of climate change, for example, we have something called Milankovitch cycles, which are connected with Earth's orbit. So we can very clearly and very precise count the ongoing change, and those cycles are visible, for example, in the changes in glaciation and deglaciation during the Pleistocene. So those Milankovitch cycles can simply describe the changes in this very cool, very cold period. And what about those different periods in the history of Earth? I know there are denialists of climate changes, especially caused by human activity, and often they use the argument that but in the history of the Earth it was warmer. Yes, it was. This is undeniable truth. For example, here in Cambre, we have plus 14 degrees of Celsius in comparison to the average from 1960 to 1990. So it was warmer, hotter even, yeah, all over the Earth. However, those changes we observe in history of Earth's climate took, for example, millions of years, hundreds of millions of years. Yeah, so those changes were very, very slow. And now, what we observe now, this is this data here. This is our time. This is 21st century here in this part of axis. And what we observe here, this is the very big rate of change. That means the change for few degrees of Celsius may be observed during 100 years, This is our future also. By the end of 21st century, the temperature should rise for another centigrade or 2 centigrades. That means the pace of change we observe now is much more higher, and this is the fact we should be aware of, and also this is the most scary part of current contemporary climate change. I mentioned this this term. So what is our role in climate change? In general, when we look at the climatic system, it is very highly self-regulated. Even if we have, for example, this very big volcanic explosion, eruption, the climate system can simply go back to the balance. However, when we add human, it is somehow more difficult for climate system, natural climate system, to go back to this very nice equilibrium state. Why is that? Well, we add our part in this in all those cycles, yeah. For example, by combustion of fossil fuels, production of cement, deforestation, and destruction of organic soil. So our influence, it's not straight connected with, for example, with atmosphere, but we can influence different elements of climatic system, and that is why this is so dangerous for global climate. For example, most of the greenhouse gases emitted by humans are long-lasting. What does it mean? That means one particle of CO2 can last in free atmosphere for 100 years. So that means when once emitted CO2 amount, yeah, of this gas, yeah, can lead to changes, can provide the changes for almost 100 years. So that is so important to remember that this is long-lasting process. Also, not only CO2 is living gas in the atmosphere, also methane connected with agriculture, and also, for example, nitrous oxide, which is connected with, for example, the fertilizing the plants. Yeah, so those are the sources of those long-lasting greenhouse gases. With those long-lasting greenhouse gases and with climate change is connected very important term, which is radiative forcing. This is a very important concept related to energy balance in atmosphere, because this is the amount of energy which is connected with given factor, and it describes the amount of energy which can influence climate system, and positive radiative forcing means that this disturbance will lead to the absorption of energy in the system. That means global warming. On the other hand, negative radiative forcing will lead to the loss of energy, and it may lead to cooling the climate system. So this is a very, very important element, and this energy is also, of course, counted in watts per square meter, and may be count for the whole atmosphere. Yeah. So, for example, this is very nice graphic, yeah, from the IPCC report from 2014. IPCC, this is Intergovernmental Panel for Climate Change. And as you can see, here we have this long living gases and their radiative forcing, which is positive, as you can see here. Also, we have information, for example, about aerosol. All kinds of aerosols will reflect solar radiation, so aerosols will have this negative radiative forcing. What is important, we have very high level of confidence that those, for example, CO2 emitted by humans is on this quite big level of radiative forcing. What is more important, IPCC also describes radiative forcing for a total anthropogenic influence, and it is always described relative to 1750. That means it is before the industrial era. For this report from 2014, we have information that radiative forcing caused by humans was at the rate of 2.29 watts per square meter, but from the report from 2021, we have information that this radiative forcing caused by human in 2019 was on the value of 2.72. So this is information that our influence on climate system is clear, and also it's very important factor for the climate changes we can observe right now on Earth. So, what is the current state of planet? Well, first of all, we maybe you've seen this picture. From year to year, we have visible increase in our Earth temperature, and this is maybe not for whole planet. For example, here you have different regions with negative anomalies. However, globally, the amount of energy which is absorbed is increasing. Yeah, that means we will observe steady increase in temperatures. We can observe it also from different kind of reconstructions of air temperature based on proxy data such as tree rings or ice cores or historical sources. And you may see that, as I mentioned, this temperature in history was higher in some periods, but the rate of the changes now is very high. This temperature is rocketing simply. To confirm the influence of humans on temperature, here you have simulated natural only solar and volcanic causes of air temperature changes, and here you have connected, simulated human and nature. That means this simulated human and nature changes are very close to the observed values. This is the proof that we have very big influence on temperature on Earth. Also, we observe it, those kind of changes in air temperature in Arctic. Why we are concerned about the Arctic? Because this is Arctic is so-called the kitchen of the weather for Europe, and the loss of sea ice in this region may be catastrophic for Europe, for climate in Europe. Not only our temperature is rising, also we observe that more and more energy is absorbed and accumulate in this upper layer of ocean. This is from 0 to 2,000 meters. As you can see, this amount of energy is rising, and this is very clearly visible rising trend. And what is happening in temperature, Earth temperature in general? To understand it, we have to consider the statistical nature of Earth temperature. That means the Earth temperature as a climate element has Gaussian distribution. That means we have quite big amount of values connected with mean value, average value. So then we have anomalies and extremes, both cold and hot. What we are observing now, this is the increase in mean values. That means this whole distribution is moving towards higher values of temperature. We also observe the increase in variance. That means this distribution will be flattened, and we will have still cold extremes, cold anomalies, hot extremes. And when we mixed those two changes, we have higher variance with higher temperatures. So we are simply going to observe more and more records in hot weather. In general, we observe hot extremes for whole Earth. This is also from IPCC report. This picture, showing us the increase in appearance of hot extremes, and they are mostly in high level of confidence in human contribution to it. What we observe more, we observe also increase in cases of heavy precipitation, as we have, for example, in last year in September in Central Europe. So we observe more heavy precipitation, and on the same time we can observe more cases of agricultural and ecological droughts. So we going to the part of weather which is more and more extreme. We often think about extreme weather, about, for example, tornadoes, hurricanes, and so on and so forth. But drought, it is also extreme weather. Please remember about this, and also, for example, the number of days with hot days. Also, this is the extreme weather. What we can observe, for example, for tropical cyclones, we observe increase in strength of those phenomena. We observe also the longer hurricane season. That means it can last from March to even November or longer. So those changes clearly increase the danger for humans. What else can we observe? We observe also changes in, for example, NAO circulation. This is North Atlantic circulation. This is the circulation which shapes weather during the cool part of the year. And we can observe that this NAO index is more positive during the last years. That means when we have this positive mode of this circulation, it means that we have more warm and wet winters in Europe and more cool and dry events in, for example, Mediterranean basin. So those are the changes we observe right now. What else is changing? We have to go to Arctic. We observe more very big changes in amount of sea ice. We have also the changes in the thickness of the ice and age of the ice. Let me show you animation which was made from 1984 till 2016, and please take a look at the age of the ice. At the beginning of this period we have very big volume of ice which was plus 4 years old, so old ice. That means the ice lasted for winter and summer and accumulate some more. But now we observe that we have very big amount, big volume of the very young ice. That means Arctic is more likely to be free of ice during the summer seasons right now. This is not very nice, not very good, for example, for polar bears, because they are hunting from ice. When we don't have this ice cover, for those animals it is difficult to get food. Yeah, so this is the change in ecosystem which is clear, visible and very negative for those creatures. What else? About glaciers. The melting of the sea ice, it's not so dangerous for us as melting of glaciers and ice caps, which are localized on the ground, yeah, on the land. Why? Because this is additional amount of water which is simply going to the ocean. Here you have some pictures from Kilimanjaro. So this is 2006, and this is the beginning of 20th century. So this recession of glacier is clearly visible, and this is not only in, for example, in Africa, but we observe it all over the world, especially, for example, in Alps in Europe. And why I'm telling about the sea level, because we observe very clearly the increase of sea level, very nice increasing trend. For given places, given ports, we can observe that the increase is even bigger than the average value, and this is caused by not only the melting of ice caps, but first of all, it is connected with physical features of water, because the first reason of increase of global sea level, this is water expansion causes by warming up of the water. Yeah, so this is the main reason we have increase in sea levels. Why this is important? Because plenty of people lives in, for example, in deltas of big rivers, and we will face very big danger for those people, and we can prepare for those changes, and also we can observe the situation that those people are forced to move somewhere else upper, for example, to avoid this increase of sea water. What else is very important? Well, this situation connected with permafrost, so ice in the ground, and high temperatures leads us to loss of the permafrost and increase in height of active layer, which may lead to this kind of damages of, for example, of housing in the areas, quite big areas in Asia here and also in North America. Consequences of the climate changes are also visible for biosphere. I believe you know that plenty of species are critically endangered, and some of them are on the verge of extinction. As you can see, the most species are from group of plants, and then we have freshwater fish, invertebrates, and amphibians. Yes, so those are the most endangered group of organisms in Earth. And also this image of the starving polar bear for me is the most powerful image about the climate changes and biosphere. What else? The changes in the ocean water can lead, for example, to coral bleaching. Yeah, so the changes are not only observed in those polar region seas, but also in the seas in general. For example, based on different regions in Europe, you may find information that, for example, for Mediterranean region, there will be increasing risk in, for example, desertification, forest fires, and, for example, droughts. And for northern Europe, not all changes are negative, because we can see, for example, the increase in crop yields. So this is positive aspect of climate changes. But on the other hand, we can observe in north melting of the glaciers. So depending on region, the causes and also the results of climate changes may be positive or negative. Always ask about which region you want to talk about in this field. In general, we can observe that the problems with climate changes and agriculture always leads to the loss of productivity. But as I mentioned, depends on different regions. The problems may be considered different elements. For example, cereal, vegetables, different kinds of crops. Why I'm saying about these regional problems? Because based on different species in different areas, may appear different stressing factors. As you can see here, for example, for soybean, we have difficulties in soil nutrition, but also, for example, the acidity of soil. Yeah, so those elements can influence the crop yields of soybean. Still, we have a big problem with illegal deforestation for commercial agriculture. Most of all in Brazil, in Malaysia, Indonesia, Bolivia, Paraguay, and also in Equatorial Africa. This is still a big problem, which we can observe since 90s in 20th century. Because of these problems with food production, we can observe also the problems with human health. because this may lead to malnutrition, especially for younger kids. And this is very, very big problem in arid areas where we observe more and more desertification of those regions. We can observe also problems with respiratory issues. We can observe problems with cardiac arrests. We can also observe the increasing dangers of, for example, infectious diseases. And this is the very important element because, for example, for Australia, we observe very big spreading of dengue virus. So this is quite a big problem for north part of Australia. And connected with the changes are also mental diseases, for example, anxiety, depression. This is much proof already that the connection with the mental state of people, for example, people working in agriculture, it is very connected with climate changes, because when I'm worrying still and on the daily basis about my crops, about my family, if I will be able to feed them, to give them appropriate sources to live, it leads to very serious states, for example, very deep depression, for example. Yeah, so those are issues connected with climate change and human health. This is very, very important for us to be aware of it and to simply sometimes to talk people with those kind of problems. This is our responsibility also. What else? Well, climate changes can influence also the tourism, and all kinds of, all the industry connected with it. For example, warm winters can be very bad for alpine region in Europe, so also depending on region, different elements connected with climate changes can influence it very highly. So from year to year we observe increase in costs of causes by natural disasters. And what is going in the future? Well, ahead of us we have different scenarios. Now we have 5 group of scenarios. Those scenarios are related on mitigation and adaptation to climate changes. And as you can see, those scenarios are divided in between different elements of socioeconomic challenges. And as you can see, we have 5 groups, and in all scenarios, climate scenarios, no matter which generation of climate scenarios we work with, we have always this low emission scenario. For example, here we have this sustainability going green. That means we are moving, the world is moving towards more sustainable approach. That means the emissions of, for example, CO2 should be reduced greatly, and so on and so forth. Those different scenarios, you can also find it in the last IPCC report, but we have different elements in each and every scenario. For example, middle of the road, this is the scenario when we observe the trends we are familiar with. Those are the same changes we observe now, And in general, we observe in this scenario that we want to go to follow the sustainable development goals, but it is, it is in the same rate we observe now. So this is not rapid change, but this is slowly change into this more sustainable approach to the environment, to the socioeconomic elements. So this is not the low emission scenario, but this is also this not very high emission scenario. The most dangerous, the most difficult for me to be familiar with is regional rivalry scenario. This is a rocky road, and here we have more and more we see here increase in nationalism. This is not so good because in this scenario we don't have this global cooperation to work for the better future. It may lead to really great imbalance in within the countries or in between the countries. That may lead to a very big risk of conflicts, connected with the climate changes. Next scenario, this is inequity with this more and more increase in this divide world. We can here see also the use of low carbon sources and high carbon sources when we think about the energy. And the last scenario, this is high emission scenario, so fossil fuel driven growth, which is simply connected with this global markets. We can observe here investment in health, education, social capital, but it is all fueled by fossil fuels. So that is why this is high emission scenario. And based on those different scenarios, we also can observe the future emission. For this high emission scenario, we have the highest values of the carbon dioxide, for example, and for this low emission scenario by the 2050, it is prognosed even to reduce it, whole emission of CO2. With those scenarios are connected, for example, global surface temperatures. As you can see, the range from this low emission scenario to this high emission scenario. The most possible are those two scenarios. And what is really interesting, by the end of the 21st century, based on 3 scenarios, the Arctic will be practically free of ice. This is quite important because we can see here not only influence on the natural environment, but free of ice Arctic will lead to conflicts connected with economy, with sources, natural sources, and also it may lead to the conflicts connected with the trading routes in the Arctic. But those are quite dark scenarios. Do we have any hope for future? Yes, we have. We have adaptation and mitigation. Those are the activities which should lead us to a better future. And for example, mitigation And those are the all activities which lead to changing approach, for example, in energy, renewable energy sources, sustainable transportation, also more efficient technologies. On the other hand, we have adaptation. So those are the actions to manage the risk of climate change impacts. And here we have, for example, flood protection, also different approaches to the emergency situations, and also changes in infrastructure, which we already have. Those adaptation strategies are quite wide, and in general, when we think about the adaptation to the climate changes and also mitigation to the climate change, we have to focus on our region. Why? Because, for example, in Europe we have over 74% of people living in urban areas, and those are areas very vulnerable to the climate changes, not only the changes in extreme temperatures, but also heavy precipitation, also the time with the atmospheric droughts, so lack of precipitation. And here is the web page, a very nice web page, where you can find really good information about how your country is prepared to the climate changes. Also, our direction of those mitigation and adaptation in the cities in Europe is simply focused on those factors connected with geography, connected with infrastructure. For example, we want to introduce to the cities more blue and green infrastructure, more efficient gray infrastructure, which can simply help us to avoid, for example, very big risk connected with flooding. So this is the situation which is quite important for us. As a conclusion, I don't want to give you the list of main conclusions, but I want to show you some pictures, very powerful pictures. First of this picture is, we all facing challenges, all continents facing challenges, but based on the growth of those of societies on this in these continents, we have a different level of those challenges. So, in general, we are in quite good situation. We have relatively moderate challenges concerning different areas of our living here in Europe. But on the other hand, we have to, for example, focus on Africa, where we have almost in every region severe challenges connected with climate changes. That is why it is so important to cooperate globally to help those regions in this situation we are now. What is more important, UN have this sustainable development goals, which are quite important for us in the future, and we should also cooperate in these areas to change this world more to this world. So this is our path to follow for the next few years. So thank you for your attention.
Thank you. Thank you so much for this lecture, for sharing all this knowledge with us about the climate, about the changes. So dear participants, now it's the time for you to ask your questions. And while we are waiting to appear, for them to appear in the chat, let me ask you a question,
Yes.
Aleksandra. How can we, by our daily actions, help, to avoid those worst case scenarios?
First of all, I believe that on the daily basis we should take care of our neighborhood. Yeah, this is the first thing I'm, thinking of, because for example, here in our city, in Torun, we have something called participatory budget. And this is very nice action, because people can decide which activities should be, financed by municipal. So we should focus on, for example, introducing this green and blue infrastructure in our communities. Also, very important element is education. So we should talk about this ecological issues, but not as I'm not big fan of chaining yourself to the trees, but to educate how we can, for example, recycle, how we can change the small changes, for example, in our shopping, in our habits, this is the most important part of this pro-ecological behavior, for the future. It is quite difficult to talk about, for example, how much we can influence, because, as I mentioned, once emitted CO2, it will last for 100 years. So we have to be, cautious about this, because the fact we will stop, for example, emitting CO2, it doesn't mean that from the day one, the next day it will be great. No.
Yes, you are just thinking about our future generations, right?
Yes.
But each and every, even smallest action counts. Like we should be turning off the light, right?
It's right. I'm I'm a big fan of it.
Because I want to leave us with this positive note at the very end, that there is hope for us after all, right?
Yes. And for example, if we stop emitting, different kinds of pollutants, to the air. For example, people with allergies, with difficulties with breathing, will feel better. So this is this short-term effect. For example, I believe that all of us simply want to, for example, have a nice time on the beach, which is not polluted with plastic bottles, cigarettes, and so on and so forth. So our actions matter, really. They are.
Okay, thank you. Thank you for also highlighting that. Since there are no comments and no questions in the chat, I believe you made the subject very clear to everyone. So thank you. And thank you for watching, staying with us. And there's actually one final slide that I wanted to share with you, with the QR code to the short survey. If you could please take 1 minute of your time and fill it in to just let us know how to improve for the future UFE academies to come. Thank you.
Thank you.